Have you ever looked up at the night sky and just felt small? That sense of wonder, like you're standing on the shore of a vast cosmic ocean? Well, what if I told you our own cosmic backyard, the solar system, is far stranger and more mysterious than you've ever been led to believe? Forget the neat little diagrams from your school textbook. We're talking about a universe of violent storms that could swallow our entire planet, moons with hidden oceans that might just harbor life, and ghostly particles from our sun that travel millions of miles just to put on a light show. Today, we're not just taking a tour. We're embarking on an expedition. We'll journey to each planet, uncover the bizarre phenomena that still have scientists scratching their heads, and reveal the incredible tech that's become our eyes and ears in the void. So get comfortable. This trip might just change how you see your place in the universe forever. Did you know there's a world out there where it might literally rain diamonds? Or a single storm on Jupiter, big enough to swallow Earth, and has been raging for the last 150 years? And what about the silent explorers? The robotic probes right now gliding through the darkness, sending back postcards from the edge of our solar system? This isn't science fiction. This is our reality. Let's get into the incredible wonders and shocking truths of our cosmic neighborhood. Our journey has to start, as everything in this system does, with the Sun. It's a star so enormous it makes up 99.8% of all the mass in the entire solar system. It's a seething, churning ball of plasma, a nuclear furnace that fuses 600 million tons of hydrogen into helium every single second. But this star is more than just a giant light bulb. It's a temperamental giant. For years, we've studied it from a safe distance, but now we have a scout. NASA's Parker Solar Probe is doing something that sounds impossible. It's flying through the sun's fiery outer atmosphere, the corona. This amazing machine, traveling faster than any object in human history, has survived scorching heat to tackle one of the sun's biggest puzzles. Why its atmosphere is hundreds of times hotter than its surface. Parker has already discovered bizarre magnetic zigzags called switchbacks that seem to be whipping particles into a frenzy, which might explain the corona's mind-boggling temperature and the origin of the solar wind. This constant stream of charged particles washes over every single planet, creating beautiful auroras and posing a constant threat to our technology. The Sun isn't just the heart of our system. It's a cosmic engine whose secrets we're only just beginning to unlock. Next stop, the most extreme world in the inner solar system, Mercury. It's the closest planet to the Sun, a tiny, scorched world that you would think would be the hottest, but it's not. Mercury has almost no atmosphere to trap heat, so its temperatures swing from a blistering 430 degrees Celsius in the daytime to a ridiculously frigid minus 180 degrees at night. Its surface is a brutal scrapbook of the solar system's violent past, covered in craters from billions of years of cosmic bombardment. For the longest time, we thought it was just a dead rock. But then NASA's Messenger spacecraft, which orbited the planet for 4 years, revealed a world full of surprises. The biggest shocker? Tucked away in craters at its poles, forever shielded from the sun's glare, is water ice. How can ice exist on a planet this close to the sun? It's a fantastic paradox that shows us just how weird and resilient our solar system is. Messenger discovered this tiny planet is actually shrinking as its iron core cools and contracts, leaving these strange cliff-like wrinkles all over its surface. We now journey to a planet often called Earth's twin. But if it is, it's our twisted, nightmarish twin, Venus. It's a world of similar size, but that's where the family resemblance ends. Its atmosphere is a toxic, crushing blanket of carbon dioxide, 90 times thicker than Earth's, creating a runaway greenhouse effect from hell. The surface temperature is a steady 465 degrees Celsius, hot enough to melt lead. The pressure is so intense, it would crush a submarine like a soda can. And the clouds? They're not made of water, but of flesh-eating sulfuric acid. Yet, even in this hellscape, there are tantalizing clues of something more. Scientists have seen strange signals that could point to active volcanoes spewing lava on its surface right now. Even weirder is the ashen light, a faint glow on Venus's dark side that people have seen for centuries, but no one can explain it. Is it a colossal lightning storm? A massive chemical reaction in the sky? Or something else entirely? Upcoming missions, like NASA's Veritas and Da Vinci Plus, plan to map this hostile world and dive through its clouds, hoping to finally figure out why Earth's twin went so horribly wrong. From the inferno of Venus, we come back home to the pale blue dot. Earth is, as far as we know, one of a kind. It's the only world with vast oceans of liquid water, a protected magnetic field, and a mind-boggling diversity of life. From here, it's easy to think we have our own planet all figured out, but we don't. We live on its surface, but we still barely understand the forces deep in its core that generate our magnetic shield, or the intricate dance of plate tectonics that's constantly remodeling our world. And our own moon, a familiar face in our sky, still holds secrets about its birth, with the leading theory pointing to a cataclysmic smash-up with a Mars-sized object early in Earth's history. Our planet is a living, breathing world, a masterpiece of cosmic luck, and a constant reminder that there's always more to explore right here at home. All right, let's head to humanity's favorite obsession, Mars, the red planet. For centuries, we've dreamed of walking on its rusty surface, and now our robotic explorers are doing it for us. Rovers like Perseverance and Curiosity are our boots on the ground, investigating what was once a world of water. Perseverance is right now in Yesuda Crater, the site of an ancient lake and river delta. Its mission is nothing short of monumental: to search for signs of ancient life. And it is finding clues. It has discovered complex organic molecules, the very building blocks of life, in mudstones that formed at the bottom of this ancient lake. Now, this isn't proof of aliens, but it's the most promising lead we've ever had. The rover has also drilled rock cores, storing them in sample tubes that a future mission will pick up and bring back to Earth. Just think about that. For the first time in history, we'll hold pieces of another planet in our own labs, analyzing them for definitive proof of life. Perseverance isn't just a robot. It's a time-traveling geologist, piecing together the story of a lost, watery world. And recent oddball discoveries, like a rock covered in tiny, mysterious spheres, just keeps reminding us how much we still have to learn about Mars's complex past. Now, prepare your sense of scale to be completely rewritten as we approach the king of the planets, Jupiter. This gas giant is an absolute monster, more than twice as massive as all the other planets put together. Its famous Great Red Spot is a storm that has been churning for at least 150 years. It's a vortex so large it could easily swallow our entire Earth. But recent flybys by NASA's Juno spacecraft have shown us a Jupiter we never knew existed. Juno's polar orbit has revealed that the planet's poles are covered in bizarre, honeycomb-like clusters of cyclones, each one the size of Australia. Juno has peered deep beneath the clouds, discovering that Jupiter's powerful magnetic field is generated much closer to the surface than we thought, and that its core isn't a solid ball, but a fuzzy, dilute mix of rock and ice. This completely upends our theory of how giant planets form. But maybe the biggest excitement is with its moons. Juno's recent flybys of Europa have detected carbon on its surface, which likely bubbled up from the huge liquid water ocean hidden beneath its icy shell. An ocean that has the key ingredients of life. And then there's Io, the most volcanically active body in the solar system, a pizza moon, covered in hundreds of erupting volcanoes thanks to Jupiter's immense gravitational pull. We now glide to the undisputed jewel of the solar system, Saturn. Its magnificent rings, stretching over 280,000 kilometers, have fascinated us for centuries. We know how they're made of countless particles of nearly pure water ice. But the true wonders of the Saturnian system were revealed by one of the greatest missions in history, Cassini. For 13 years, Cassini orbited Saturn, completely rewriting our understanding of this world and its moons. It found new moons and showed that the rings were an active, dynamic laboratory of how planets form, with tiny propeller moonlets carving paths through the ice. But Cassini's greatest discoveries were two of its moons. First, Titan, a world bigger than Mercury that's wrapped in a thick nitrogen smog. Beneath that haze, it has a landscape that looks eerily like Earth, but with a terrifying twist. Its rivers, lakes, and seas are not filled with water, but with liquid methane and ethane. And then there's Enceladus. This tiny, ice-covered moon absolutely stunned scientists when Cassini found massive geysers of water vapor blasting out from the tiger stripes at the South Pole. Cassini actually flew through these plumes and tasted them, finding water, salt, and organic molecules, all the ingredients for life as we know it, just jetting out into space from a subsurface ocean. It's arguably one of the most exciting places to look for life beyond Earth. Our journey now takes us to the far, frigid reaches of the solar system, to the mysterious and barely explored ice giants. First up is Uranus, the planet that spins on its side, probably knocked over by a massive impact billions of years ago. Its seasons are beyond extreme, with each pole getting 42 years of non-stop sunlight, followed by 42 years of total darkness. Its calm, blue-green color comes from methane in its atmosphere. Next is Neptune, the farthest true planet from the Sun, a world of deep blue and supersonic winds, the fastest in the solar system, that whip dark storms across its face. Both are enigmatic worlds we've only visited once, with the Voyager 2 probe way back in the 1980s. Scientists believe that deep within these planets, the immense pressure could be so great that it compresses carbon atoms into solid form, creating what could be a literal rain of diamonds. Past Neptune, we enter a vast, dark, and frozen kingdom, the Kuiper Belt, home to countless icy bodies and dwarf planets. This is where we find Pluto, once considered our 9th planet. NASA's New Horizons mission showed it to be a stunningly complex and active world when it flew by in 2015. It has towering mountains made of water ice, vast plains of frozen nitrogen, a surprisingly hazy atmosphere, and a giant heart-shaped glacier. New Horizons then flew on, making a historic flyby of Arakath, a bizarre snowman-shaped object that is the most primitive body we've ever explored. It's a perfectly preserved relic from the dawn of the solar system, and the discoveries just keep coming. Data from New Horizons suggests the Kuiper belt might be far larger than we thought, or that there could be even a second Kuiper belt out there, waiting to be explored. And far beyond that, in the theoretical Oort Cloud, trillions of comets might be lying in a deep freeze, silent witnesses to our system's birth. So how do we know any of this? How can we see a storm on Jupiter or a mountain on Pluto? It's all thanks to an incredible fleet of technology. Robotic landers like Perseverance are our hands and our geologists on other worlds. Orbiters like Juno and the legendary Cassini are our long-term observatories, watching how planets change over years. And space telescopes are our windows to the wider cosmos. Hubble gave us our first clear views, and now the James Webb Space Telescope is rewriting the book on astronomy, peering through the atmosphere of alien planets and seeing the birth of the very first galaxies. And the future? It's even more exciting. Artificial intelligence is becoming essential, helping scientists find patterns in data that no human could ever spot. Reusable rockets are making space cheaper and more accessible than ever. And radical new ideas are on the drawing board. Nuclear thermal rockets that could slash the travel time to Mars. Factories in space using 3D printers and advanced habitats to create a permanent human presence on the moon. And one day, beyond. We are building the tools, not just to see the universe, but to live in it. From the fiery heart of our sun to the icy darkness beyond Pluto, our solar system is a place of endless wonder, spectacular beauty, and deep mystery. Every planet, every moon, every speck of dust tells a story that's billions of years in the making. We've learned so much, but we've really only just begun to scratch the surface. What secrets will we uncover next? Will we find evidence of life in the oceans of Europa or Enceladus? Will we finally hold a piece of Mars in our hands? The journey is far from over. If you're as fascinated by all of this as we are, and you want to be there for the next great discovery, then do us a favor. Hit that like button, share this cosmic journey with your fellow stargazers, and subscribe for more explorations of space, astronomy, and the tech that makes it all possible. Until next time, keep looking up.